UNiCEN was established in October 2014 under the National Research Foundation, or NRF, Corp Lab at University scheme. It is a strategy of NRF to try to bring university research to market through this funding mechanism. In this case, the company we work with is Fujitsu, and this lab aims at developing technology and models for solving urban and social challenges. To achieve the UNiCEN vision, we take a end-to-end approach, which we call from sensing to decision making. We first understand from data the dynamics of congestions, queues, and crowds, for example. And then using the insights that we derive from data, we then design simulation and optimization model that will help us optimize the operations. And these operations could be transport operations or logistics operations or public safety and security operations. Both people and goods share the same road network, if you think about it. So how do we turn the negative energy generated from waiting in crowds and queues into positive energy for urban dwellers, for business enterprises with the use of technology is the fundamental research challenge we have to face. To do that, we adopt a vision tagline which we say, adding capacity without building capacity. This in layman terms really means doing more with less. There are 4 clusters of projects that we are working on. One is in urban mobility, the other one is in urban logistics, and the third has to do with port and maritime optimization, Singapore being a port city, and finally is public safety and security.
Yeah, so essential idea over here is to utilize real-time big data analytics with all the information that's flowing in, coming in real time. We kind of know where are their position, where are their status. So we try to, based on that information, make prediction about where the demands are, and also based on the real-time location, come up with the best recommendation that we can offer to them. And the purpose is to reduce their free roaming time. All these recommendations, as you see on the screen, that they are represented by red boxes. Right? All they need to do is try to approach the red box and place themselves inside that box. We will further display like which are the streets, which are the taxi stands that have a high demand potential. But if somehow they don't like the destination, they can drive away any way that they want. After a while, a couple minutes, the system will sense that a new recommendation will be generated and sent to them. Even for the most experienced driver, their feedback is that having the guidances telling them what's happening on the ground, what kind of recommendation should be followed, is immensely useful for them. And I think the most remarkable result that we get is that on average, if drivers are following our guidances closely, they can get a 24% reduction in their free roaming time.
We have a project which is in collaboration with IMDA. It is to design a national platform that coordinates urban logistics activities for a truck-like Singapore. I think according to statistics, there are just about 20-odd thousand of taxis and 40-odd thousand private hires, which adds up to about 70,000 of such urban transport vehicles on the road, compared with 160,000 trucks and vans. So in the same way as we try to discourage people from driving to foster car-like Singapore, we should also be thinking about how to foster a truck-like society. And that is the essence of our work there. The project that we work with is called the CUDO project, and CUDO stands for Collaborative Urban Delivery Optimization. It is precisely to meet this next growth phase of the in-mall delivery initiative announced by Deputy Prime Minister Tharman Shanmugaratnam way back in 2015. What it hopes to do is to develop optimization models and analytics for collaborative last-mile delivery to retailers under the IMD concept. If you think about it, in today's internet, we move information with very high efficiency. across the internet. In the physical world, when we are moving packets, okay, we can call this the physical internet, where the ideal situation is to allow packets to move across from its point of origin to the point of destination seamlessly with the use of standards, with the use of protocols, and with the use of sophisticated routing algorithms. One such protocol that we advocate in our work is what we call Urban Consolidation Center, which is a place where inbound shipments from outside the city will gather, and they do cross-docking and consolidation before it gets to be outbound into the city. The Maritime Traffic Management, or the MTM project, is really in collaboration with the Maritime and Port Authority of Singapore, MPA. We know that every day there are about more than 1,000 vessels that sail through the Singapore and Malacca Straits. It is critically important for enhancing navigational safety in crowded waters such as ours. In view of this goal, we initiated R&D to develop technology for maritime traffic management, employing a diverse strength from Fujitsu to IHPC and SMU, which is ourselves, with the support of MPA. So what we hope to do is to develop the first of its kind integrated intelligent transport or traffic management system that senses and predicts near misses and collisions, and more importantly, to try to coordinate the movement of vessels in real time. The SMU contribution in this project is to apply what we call multi-agent AI technology. Multi-agent technology has been used quite extensively in coordinating movement of robots, unmanned vehicles, whether you're talking about aerial vehicles or ground vehicles. Now, in this project with MPA, we are breaking new ground in trying to propose a next generation unmanned ship coordination technology that is akin to what we see in air traffic control, yet it is quite different because we need to respect the constraints that is at sea, which is quite different from the constraints in airborne traffic. But we believe that this technology can potentially disrupt the next generation vessel traffic management to reduce human errors and to improve navigational safety. What we hope to do is to develop AI technology to help us prevent collision. Now, each time when a collision happens, it's always one too many. Many lives could be lost and millions of cargo could be at stake. So this technology would help port authorities as well as vessels to mitigate any kind of chance of collision. And I think that actually is a very important social impact. For public safety and security, we are working with a local security agency to do what generally is termed as predictive policing. We are taking a data-driven approach. Basically, we study call data of occurrence of incidents over multiple years. And from there, we understand how hotspots of crimes can occur over space and over time. And with that understanding, we then develop models that allocate resources, and these are namely security agencies and vehicles, to be positioned at strategic location at the right time, so that when an incident occurs, these resources or these assets will be able to arrive at the crime scene with the least response time. We are living in a society that is aging. And we're living in a society where manpower is constantly at stake. So how do we do more with less is again a challenge. So by having this sort of technology to do more with less, we are able to use less bodies on the ground to help build a safer and more secure society. Many of us know Fujitsu to be a hardware company focusing on things ranging from supercomputer to desktops to sensors. Fujitsu has also started a new line of business in providing what they call human-centric solution, leveraging on AI. And this is why they took an interest in SMU, working with us as well as A-STAR's Research Institute to leverage on our capabilities in AI and data analytics to help them to develop products into the future.